x-axis and y-axis, and already I have considered a rigid body like this, and this rigid body in a plane has two translation and one rotation. And if I consider another rigid body like this, so this is a body 1 and this is a body 2, and these two bodies are hinged, are pinned at this position O. So we will see how these combined degrees of freedom are affected. So individually body 2 has 3 degrees of freedom and body 1 has 3 degrees of freedom. But now after hinging, if the body 1 is moving along the x-axis, body 2 also has to move along the 2-axis, and if it is moving along the y-axis, body 1 is moving along the y-axis, then body 2 also compelled to move along the y-axis. So translation motion of the body 2 is no longer independent, but it's dependent on the body 1, and body 1 can rotate about this point O, and body 2 also can rotate about the point O. So body 1 has here one rotation plus 2 translation, but whereas body 2, it has only one rotation about the O, but its translation motions are no longer independent, but they are dependent on the body 1. So it has only one rotation, and these two translations are constrained. So can we write the degree of freedom of the combined system that equal to, for body 1 we have 3 degrees of freedom and there are no constraints, plus body 2, actually we need to have 3 degrees of freedom if it is a independent not hinged up to the body 1, but because of hinge 2 constraints came. So this is a body 1 degrees of freedom, body 2 degrees of freedom. So for example, this can be written as 2 into 3, where 2 is the number of links n. So here in this case we have two bodies, that's why here n equal to 2 and 2. So this can be written as 3 into n, where 3 is the degrees of freedom of a link in a plane and n is the number of links, minus 2, where 2 is the number of constraints that is due to this hinge point. So this is the formula that we have derived at, and now we will see what happens if I make this body 1 as a ground. That means if I fix the body 1 to the ground like this, so this is the body 1 and this is the body 2, this is the body 2 and this is the point O, and body 1 is fixed to the ground now. This is the body 1. So body 1 lost is it's 3 degrees of freedom, and body 2 has only 1 degrees of freedom, that is a rotation about the point O. So now degrees of freedom of the system can be written as, here for the body 1 we can written, actually it should have 3 degrees of freedom, but it is fixed to the ground or it made as a ground, so it lost 3 degrees of freedom, and we impose 3 constraints, 2 on translation, 1 on rotation. This is for the body 1, and for the body 2, actually in a plane it has to have 3 degrees of freedom, but because of hinge joint we lost 2 degrees of freedom, that means we impose 2 constraints, so we can written like this. So if I write this one like 2 into 3 degrees of freedom, for 2 links we have, this is a number of links 2, for 2 links 3 degrees of freedom, but this one and this one, this is the constraint for 1 degree because this is a constraint for the body 1 because it is a fixed one, and this is the constraint for the body 2. So if I take 3 as a common, 2 minus 1 minus 2, where 2 can be written as a number n, 3 into n minus 1 minus 2. So the same equation, I mean whatever we derived in the previous chapter, previous example, here also we got the same equation but with a minus 1. Why? Because here n is decreased by minus 1, that's because one link is fixed, and we consider this as example 1, and in example 2, here instead of 2 bodies, now I will consider 3 bodies. So this is the ground one, and to the ground we have a body 1 is hinged. This is the body 1 and this is body 2, and to this body I hinged another body 3. So this body 1 has a 0 degrees of freedom because it's a fixed, and body 2 is fixed to this one, so it has only rotation, it lost its 2 translations, and body 3 is hinged to body 2 and it lost 2 translation, and it can rotate only about this point O1, and this is the O. So what is the degrees of freedom of the combined system? That can be written as, first we will write what could be the degrees of freedom of the body 1. For the body 1, actually it should have 3 degrees of freedom, it is not fixed, but since it is a fixed, it lost all its 3 degrees of freedom. So we impose 3 constraint here. This is for the body 1, that's a fixed one, plus for the body 2, 3 degrees of freedom in a plane, but how many constraints? 2 constraints, so 2 translational constraints. And for the, this is for the body 2, and for the body 3, 3 minus again 2, so this is a body 3. So this is a 3 degrees of freedom for body 1, 3 degrees of freedom for the body 2, 3 degrees of freedom for the body 3. So we have 3 bodies, so that's why 3 into 3. So I can write 3 into n, where n is the number of links, minus 3 minus 2 into 2. So 3 into n minus 1 minus 2 into, here I would like to write one more, this instead of 2 I would like to write here as a P1. So let's define what is a P1. Here P1 is the number of pairs with dy of 1. So number of pairs having the degree of freedom 1. For example, in this case, if I consider body 1 and body 2, how many pairs? Only one pair. 1 and body 1 and body 2, that constitute only one pair. So this one pair has only 1 degree of freedom between these two. So not total degree of freedom between these two, because about this point O it can rotate. Point this can rotate, and about point 1 about point O the body only can rotate. So it has only 1 degrees of freedom because of this hinge point. And if I consider this example, between body 1 and 2 we have one pair, and that pair is having only 1 degrees of freedom, because here hinge is used to connect the body 1 and 2. So that is a one pair, and we having the degree of freedom 1, and between the body 2 and 3 once again it's connected by hinge point. So we have one more pair having the degree of freedom 1. So how many? 1 plus 1, so here 2. So this is the P1, and here also we can write P1, but in this case what is the value of P1? That is the only 1, because we have only one pair of links that is with the degree of freedom 1. But here in this case P1 equal to 2. Here in this case P1 equal to 2. Why? Because here we have 2 pairs having degree of freedom 1. So in a general sense, can we define dy of equal to 3 into n minus 1 minus 2 P1. So here n equal to number of links, and this degree of freedom formula for the mechanism, where in a mechanism one link is fixed, and this P1 is a number of pairs having degrees of freedom 1. So we defined up to this point. And our next example is this one. Here we have a hollow cylinder. this is the hollow cylinder, this is the body 1 and this is body 2, and this is also cylinder. The cylinder is moving inside a hollow cylinder. This hollow cylinder is a fixed one. So we have already seen when and this is a side view. If you see this one, this is the fixed one, this is the fixed cylinder, and inside the fixed cylinder this blue one is the solid cylinder, and it can rotate like this, sorry, it can translate in this direction, and it can also rotate like this, it can rotate like this. So it has 2 degrees of freedom. So degrees of freedom between the body 1 and 2 is 2 degrees of freedom. I mean it has one translation and rotation. So we would like to write degrees of freedom of the combined system. For the body 1, actually if you consider the body 1 in a plane, it should have 3 degrees of freedom, but since it is a fixed, 3 constraints are imposed. This is for body 2, body 1, and for the body 2 it should have how many degrees of freedom? It should have 3 degrees of freedom in a plane, but in a plane 3 degrees of freedom, but here only 1 degree is constrained, that is along this direction, but it is rotating and translating, but in this direction translation is constrained. So only one constraint. This is for the body 2. So this is link 1 3 degrees of freedom, link 2 3 degrees of freedom. So can I write 3 into 2 or 3 into n minus 1? Why? Because here n is number of links, that is the 2 minus 1. So here n is the number of links. Here if I substitute n equal to 2, again we get the same number. So what is the value of this one? 2 degrees of freedom. If I put n equal to 2, again we get 2 degrees of freedom. And here instead of 2, in the next example, here I would like to consider 3 bodies. So 3 bodies having like this. For example, this is the body 1, and this entire structure, instead of fixing everything, I removed this fixed one and I just attached one hinge here like this. I attached one hinge here, and this is the again solid cylinder that is moving inside the hollow cylinder. This is the body 2, that is a hollow cylinder, and this is the body 1, that's a fixed ground, and this is the body 3. So here body 2 is only rotating with respect to body 1, and body 3 is translating in the body 2 and as well as rotating about this axis. Actually if you draw an axis here like this, it is rotating about this axis. So body 3 is rotating, so that means it has 2 degrees of freedom with respect to body 2. Body 3 has 2 degrees of freedom with respect to body 2, and body 2 has only 1 degree of freedom with respect to body 1. So here I can write degrees of freedom of the whole system. dy of equal to, for the body 1 it should be 3, but it lost all 3 because it's a fixed one, and for the body 2 it should be having 3 but 2 constraints, because only one rotation is possible at the point O. So 2 constraints, and for the body 3 but only one constraint, because it has a 2 degrees of freedom. So can I write like this? Only one constraint for the body 3. So this can be written like this: 3 into n, again minus 1 minus 2 minus 1. So here this n is number of links. Here in this case it's a 3, and this 2, and you have 1. So this can be written as 3 into n minus 1 minus 2 into P1 minus 1 into P2. So where P1 we have already seen. What is the P1? And if I compare this equation, if I compare this equation with this equation, in the above equation this 2 is missing, but here in this equation we got 2. That's because we got some hinge joint, and because of the hinge joint we got one extra pair of link that is having degrees of freedom 1. So that's why we got 2, and whenever we use a pair that is having degrees of freedom 2, we are getting only one constraint. So here in this case, that's why this hinge joint is missing, and we have a pair of the links that is having degrees of freedom 2. So that's why only one constraint. So what I am trying to summarize here is, this can be written as P1 into P2, where P1 is the number of pairs of links having degrees of freedom 1, and where P2 is the number of pairs of links having degrees of freedom 2. Here in this case P2 is how much? What is the P2? This is the only 1, because here what P2 pair is, P2 pair is only 2 comma 3. These two links are having degrees of freedom 2. And what is the P1 in this case? P1 equal to only 1 and 2. That is the links are pair 1 and 2, body 1 and 2 as a degrees of freedom 1 between them. So finally we can insert one more term here, 1 into P2, where P2 is the number of pairs having degrees of freedom 2. So this is the final formula that we have already seen at the starting of this chapter. So we have derived this formula with a set of examples, and here before further moving, I would like to explain one more concept. Like in the previous session, previous example, we have considered this example, like one body is this is a body 1, and this is the body 2, and this is the body 3. So instead of having hinge here, if I write these 3 bodies like this, this is the body 2 and this is body 3, this is 2 and 3. So is there any difference of calculating degrees of freedom in this case? No. Let me see that. For example, body 1 degrees of freedom is, in this case what is the degree of freedom of the system? That is 3 minus 3 0, 3 for the body 2, 3 minus 2 1, and for the body 3, 3 minus 2 again 1. So 1 plus 1, 2 degree of freedom. And for this one, for the body 1, what is the degree of freedom? That is the 0. For the body 2, what is the degree of freedom? 3 minus 2, because it's a translation is constrained, so that is 1. And for the body 3, what is the degree of freedom? That's again 3 minus 2, so 1. So in the both cases degrees of freedom are 2, and here we have used 2 hinge joints, but here instead of using 2 hinge joints we used only 1 hinge joint. But if we go from the formula, what is the degree of freedom? That is the 3 into n minus 1. Here n is a 3. 3 into n minus n. 3 minus 1 minus 2 into P1. So what is the P1? So P1 is the number of pairs having 1 degree of freedom. So here what is the pairs? So can we write pairs like this? So one may attempt to write pairs like this: 1 2, 1 3, and then 2 3. So how many pairs we got here? 3. So that means P equal to 3. So if you substitute this one, how much this one? 6 minus 6. then we get degree of freedom as a 0. So that means number of pairs that we calculated here is wrong. So we should remember this one. So don't tempt or don't confuse to calculate number of pairs here as a 3. Why? Because here we are using only one hinge joint at the point O. So with one hinge joint we are connecting all three these bodies. So that means or let me say for example at the point 1 we have a projection like this, and this link 2 and link 3 already connected to this 2 and 3. These are already connected and formed a pair with a hinge joint like this. Okay, so this is already a pair, and how many pairs? This is the one pair, p1 equal to one pair here. And if I put this hinge joint in the body 1, this is the body 1, and I just simply putting this hinge in this needle like this one. So this already one pair is together considered as a one link, because it's already formed a pair, and that is kept in this needle. Again with 2 and 3 together considered as a one link, and 2 and 3 and 1 formed another pair. So here how many pairs? P1 is 2 pairs. 2 pairs having degrees of freedom 1. So whenever we have a situation like this where more than two links are joined with a revolute joint, then P1 or number of pairs having degrees of freedom should be taken as for example, these are J links. How many links? These are J links at this particular joint. So P1 at this point equal to J minus 1, simply J minus 1. We need to take, and we should remember this formula. This is very, very important. And P1 at this point is J1, where J is the number of links at this particular joint O. Okay, this is not equal to number of n. In this case it became J equal to n, but if you have a further something like this, I have link like 4, so here n is 4, but J is again 3 at this point O. So how to calculate number of pairs having degrees of freedom at point O is J minus 1, so 3 minus 1, so that is a 2 here, and one more point here, so that is a 1. 2 plus 1 3 in this particular case if n is a 4. So this is how we need to calculate, and we should remember this one. Degrees of freedom equal to 3 into n minus 1 minus 2 p1 minus 1 into p2. Here minus 1 because one of the links is fixed, and what if link is not fixed? So if any one of the links are not fixed, then this formula is simply this. So this minus 1 will be removed, and this is the formula, and these two formulas are for the planar mechanisms.